Okay, this is the last lesson of the year. All right, our lesson begins with the idea of an oblique triangle. So who remembers what is an oblique triangle? Yeah, Mia. Okay, an oblique triangle is a triangle with no 90-degree angle, okay? So far in trigonometry, everything that we've been studying, right? We've been able to solve triangles that have a 90-degree angle in them with our definitions of trig functions. So, an example of an oblique triangle is something that just kind of like this, right? Well, how do we solve a triangle if there's no right angle in it? Well, we have to use something called law of sines or the law of cosines, right? Now, the way the book introduces this particular triangle, oblique triangles, is they give you three angles, and they use capital letters to denote the three angles, so A, B, and C, and they use lowercase letters to denote the sides, and the sides are always across the angle. So, for example, little a is going to represent the side that's across from angle A. Little b is going to represent the side that's across from angle B, and little c is going to represent the side that's across from angle C. Does that make sense? Okay, so that's how the book sets up everything. You need to know that. And also, what does it mean when we say that we're going to solve a triangle? What does that mean?
You solve all sides and the angles.
Yes. Yeah, you need all 6 parts, right? And what are the 6 parts?
Angles, sides.
3 sides, and you need 3 angles. Okay, good. So just making sure we all understand what does it mean to actually solve an oblique triangle. We need those 3 things. Okay, in the same box here, I'm going to move over just a little bit to give you some heads up. Okay, there are 4 possible cases that we are going to need to take a look at when we are solving oblique triangles, all right? Here are the 4 cases. You are going to be given some information, all right? And the information that you're going to be given about an oblique triangle, you might be given something as the angle, a side, and an angle of a given oblique triangle. So you might get a side that's between 2 angles. What did I do wrong here? What did I do wrong? Oh, sorry. Cases. Oh, yeah. 4 cases. Sorry. There we go. Okay. Sorry. Put an extra S in there. 4 cases. So, follow along. I got angle, side, angle. I could also have angle, angle, side. That's okay.
Angle, side.
Now, I could also be given this one, side, side, angle. Ooh, remember, this one's a special one, right? Yes, this is called the ambiguous case, all right? And the reason it's called the ambiguous case, with spelled correctly, the reason it's called the ambiguous case is because when you were in geometry class, you were never, ever, ever allowed to say that 2 triangles were congruent by side, side, angle. And today we find out the reason why, okay? Now, if you spell it a different way, then it's going to spell a bad word. And they always said, well, you can't spell it, you can't, say a bad word in geometry. There's no angle, side, side in geometry.
That's easy.
That's easy to remember, yeah. But today, it's called something different. It's called the ambiguous case, so we're going to study it, okay? Now, there are other cases. The other cases I could give you are side, angle, side, or I could give you side, side, side. All right? There's no angle, angle, angle. No, there's no angle, angle. So this is how we solve these, okay? Now, continuing on from this, you have to realize, if you are given one of the top 2 scenarios, if you're given angle, side, angle, 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 side, or side, side, angle, known as the ambiguous case, then in order to solve that triangle, you use the law of sines. Okay? That's what we're going to use in order to solve these triangles. So today our focus is going to be on solving these top 2. Now, if you are given side, angle, side, or side, 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 you use what's called the law of cosines. All right? So that's what I'll get to next week. But so today our focus is going to be on the top 2 cases with regard to the ambiguous case being a special case of the law of sines. Everybody cool so far? Okay, so what is the law of sines? If I had more time, I would actually show you the proof for the law of sines because it's actually kind of neat, and pretty straightforward to follow, and I believe you guys are at the level you could follow it. But because we're running for press of time for this year, I'm going to just give it to you, all right? So the law of sines is nothing more than a ratio. So if you are given a oblique triangle where A, B, and C are the angles given, and little a, little c, and little b are the sides given in opposite the angles, then we have this relationship. The sine of angle A, remember that the bigger letters, the capital letters are angles, to side A is the same as the sine of angle B to side B, which is the same as the sine of angle C to side C. So it's nothing more than a ratio. Now the cool thing is that you could also represent it the other way. I see your hand, hold on. You could also represent it the other way. You could also have A over sine A equals B over sine B equals C over sine C. It doesn't matter. The only thing you can't do is have a combination of the two. Like I can't say the sine of A over side A is equal to B over sine B. I can't just mix them up, all right? But this is how the book has presented it, and I wanted to show you the exact same way the book presented it. Okay, so here's a classic example of how the law of sines works. So I've given you an oblique triangle, and I have given you some information about this oblique triangle. Agreed? Yeah, that says A is 4 inches, okay?
Oh.
I have given you this. I have given you this angle over here, so that's an angle. A stands for angle. I've given you this angle over here, that's an angle, and I've given you this side over here. So I have given you an angle, side triangle. That implies we use the law of sines in order to solve it. Does that make sense to you so far? That's the first thing we do. Okay, then the next thing I always show that my students is I always give them, okay, I set this little t-table up. I do angles on one side, and I do sides on the other, directly opposite. Okay, it really helps you see all the information that you need to get. Okay, so A I already know is 40 degrees. B I already know is 60 degrees, and little a I already know is 4 inches. I need to then solve for these other three pieces here. Yeah. And if you're thinking already, then we already know one of them already. Which one do we know? We know angle C because we know something about a triangle, right? What do we know? They all have to be 180 degrees, so I'll use red over here, right? So, Flowrider, how much would angle C have to be? How much? 80 degrees. He says 80. Is he right? Yeah, that has to be 80 degrees. So we get one of them for free. That's kind of nice. So the only thing that we have to do now is figure out side B and side C. And to do that, we're going to use the law of sines to help us out because I have an angle side situation. So I'm going to go ahead and set up the only law of sines that I can so far. I'm going to say the sine of 40 degrees over side A, which happens to be 4 inches, okay, has to be the sine of 60 degrees all over side B. You guys okay with this? Yeah. Okay, good. Now I'm going to do some algebra here. I'm going to cross multiply. So that means I'm going to work down to show you. That means that B times the sine of 40 degrees is equal to 4 times the sine of 60 degrees. And I want B. So I'm going to divide both sides by the sine of 40 degrees. Are you following along with this? Okay, I'm not going to do that step from now on, just show you once, okay? So therefore B is approximately whatever this happens to be in the calculator. So let's get our calculators out. Okay, here's how you correctly plug this in. Make sure you're in degree mode. So I want 4 sine 60, and I just push enter to get the answer for that. And then I divide it by sine 40. Sine 40. All right, and I am getting an answer of 5.389. So we'll go to, I guess, one decimal place is fine, whatever the book wants. So I'm getting like 5.4 what? That would be 5.4 inches. So then I always come back here and say, okay, that's 5.4 inches. So we're not done because we still need side C. So I like to set up the same one again. So I'm going to say, okay, sine 40 degrees over 4 inches. Why would I use the same one that I was using before? Yeah. Yeah, because what if B was wrong or approximated wrong? So I'm going to use the one that I was given to me, right? So that has to be the sine of 80 degrees, which we know, over side C. So therefore, C is equal to 4 sine 80, all divided by sine 40. So we plug that into the calculator, and what are you guys getting? 6.1? Okay, I think that's actually right, 6.1 if I look at my notes. Yeah, I got 6.1 too, okay. All right, the rest of the day is going to focus on this thing called the ambiguous case. And the ambiguous case happens whenever you are given two sides and an opposite angle. So side, side, A, or if you rearrange it, it'll spell that word. Okay, you must always consider the ambiguous case whenever you're given this condition right here. Whenever you have that condition, you have to consider the ambiguous case. That being said, there are three possible scenarios that could happen with the ambiguous case. 1, 2, and 3, and we got to be able to identify and deal with each specific case. Okay, given side-side angle, it may be possible for you to construct one triangle only. That may be a scenario. It may also be a scenario that you can construct two triangles, two separate ones. Okay, I'm going to show you what I mean. And then it may be a scenario given a side and an angle that there can be no triangle constructed ever. No, you can't make three triangles. There's only two. It's either 1, 2, or none. Okay, so I'll repeat again. So if you were given a side, and an angle, then you have one of these situations to consider. Okay, there may only be one triangle that you can draw. There may be two separate distinct triangles you can draw, or there may be no triangle in which you can draw. And we need to be responsible for all three particular cases, all right? The first one, this is a normal case. This is just nothing big. This is normal. Okay, we can easily do that one, okay? The second one, this requires a lot of work. Okay, that's the bummer. And the third one, this is the easy case. The really easy case. It doesn't require anything. Everyone's stoked on that one, okay? So what I'm going to do is I'm going to give you an example of each of these to finish out our lesson for the next three boxes, okay? So 5, 6, and 7. We're going to start with the most challenging one first and end with the easiest one, okay? That's what's coming up next. All right, we're going to do an example of side-side angle where there are two triangles possible. All right, two triangles possible. Yep, there you go. We're going to do that. So here we go. I'm going to give you this information here. So I'm going to give you an A, a B, and a C. All right, little T table here. And then a little A, a little B, and a little C. Okay, so I'm going to tell you that A is 20.5 degrees. Okay, 20.5 degrees. Little A is 12 feet. 12 feet, and little b is 31 feet. That means that angle B is something and angle C is something, and we're not sure what it is. And we need to solve that. So we need this information in order to solve the triangle. We need these three parts. Okay? What's that? No, okay. Yeah, we're going to get there. We're going to get there. But, okay, now consider this. Now that you have this, draw the picture. Okay? Draw the picture of what's been given to you. So here's A, here's B, here's C, here's little c, here's little b, and here's little a. Okay? What do I know? I know that this is 12 feet. I know that this is equal to 31 feet. And I know that this is 20.5 degrees. So analyze what you have. You have an angle, you have a side, and you have a side. So if you have angle, side, side, you have to consider the ambiguous case. That's what we're doing here. And I'm telling you ahead of time that there are two triangles, and I'm going to show you why and how to get it, that they're two triangles.
In that one triangle?
So once we have now established that we're dealing with the ambiguous case, this is the really fun part. This is where you have to do the analysis. You have to immediately then go over here and figure out what I call the leftover angle to split between the other two. So do you see that I have an angle C and an angle B, and I don't know what they are, right? You guys agree with that? But I do know something about triangles altogether, and their sum has to be 180. So how much do I have left over to split between angle B and angle C? Yes, I have 159.5 degrees left over. This is going to be a key part to understanding the ambiguous case. This is what I call the leftover, okay? And I teach this very different than what the book does. So it's all based off of this leftover angle. So that means that between B and C, I've got 159.5 degrees to spare between the two of them. Agreed? All right, sweet. Now, we set up the only law of sines that Flo saw earlier that we can do. We can only do one of them here, all right? It's this. It is the sine of 20.5 degrees over what, everybody? Over 12 is equal to what? The sine of angle B over what? Over 31. That's the only thing I can do. I don't have any other options available to me, so I have to do this, all right? All right, so we're going to go ahead and I'm going to move this up and do some algebra here. I have now see that the sine of angle B is worth 31 times the sine of 20.5 degrees, all divided by 12. But am I interested in the sine of B, you guys? No, what am I interested in? I'm interested in B itself. So therefore, B is going to be the inverse sine of whatever this number is. So I use that number and I put it into my calculator. So let's take your calculators out. Tell me what that number is going to be. Okay, so I'm going to do 31 sine of 20.5. So I get that, and then I divide that by 12. So I'm getting 0.904702, blah, 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 blah. Okay? 0.904702. So I'm going to put this in here. 0.904702, blah, 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 blah. So I now have the B is the inverse sine of this. Now the cool thing about your calculator is that you should realize that if I want the inverse sine of this number, all I have to do is say inverse sine of second answer. It just automatically stores it in my calculator. I'm sure you guys already know that, but just to show you again. All right, so I'm getting 64.78 if I go to 2 decimal places, okay? So now this is approximately 64.78 degrees. Okay. This is a clutch moment in this particular box. Because now, what do I know?
You can subtract.
I know I have 159.5 degrees left over to spend. So is 64.78 an acceptable answer to get? Yeah. It sure is, because it's smaller than that, so I can afford to spend it, right? Okay, here's the key part though. There is another angle whose sine is equal to 0.90470 blah 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 blah. What's that? You're close. You're close. How'd you get that? 154. Where does that come from? Huh? You're close. You're close. It's subtracted from 180. Okay? This dates back to the unit circle, okay? Think about the unit circle, right? Think about an angle in quadrant number 1 and think about an angle in quadrant number 2. If I take 30 degrees, for example, the sine of 30 degrees is the same thing as the sine of 150 because they're both in quadrant 2, they're both positive, they're both reference angles, they're both 30-degree reference angles. So here's the deal. This is what everybody always forgets. The other angle is 180 degrees minus 64.78, which gives me, if you just go in the calculator, right? Just go 180 minus second answer. So you can take advantage of that, and you get 115.22. If I go to 2 decimal places, 115.22. So I get 115.22 degrees. So check it out. There are 2 angles in the world whose sine is exactly 0.90470 blah 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 blah. I'll prove it to you right now. If we ask the calculator for this, if I ask the calculator for the sine of 64.78, the calculator is going to tell me it's that ratio, 0.904 blah 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 blah. And then if I ask the calculator for the sine of 115.22, notice it gives me the exact same answer. So there are 2 angles whose sine is equal to the ratio that we have been given. So how do I put all this together? How do I synthesize this information? It could be this angle or this angle, and how do I know which one to pick? Why do I pick both?
Two triangles.
There it is, because they're both under 159. That's where the two triangles comes in. They're both under 159. So you can imagine for just a second with me that if this were the case where there was only one triangle possible, then our second angle that we get would be too
Bigger than that.
it'd be too big. It'd be too big. Okay? It'd be too big. Too much. Okay? So now, how do we continue on from here? That's where we're going next, okay? Okay, so we have to go on and solve both triangles, right? In this scenario, the A and the little a and the little b are going to stay the same. So this is going to be 20.5 in both, right? 20.5 in both. Little a will be 12 in both. Little b will be 31 in both. 31. So right there you can see that, okay, I've got this information, that information. These three pieces are all the same in both triangles, right? But what's different? Angle B is in one triangle is going to be worth 64.78, and then in the second triangle it's going to be worth 115.22. So there's the difference. You guys see it? This is why there's two different triangles, right? Okay, I'm going to go ahead and just tell you what the answer is when we plug these in. For this first one, little c would be 34.15, and little c over here would be 23.9, and then we could easily just get the other angle by subtracting 180 from the rest of them. But you would have to go ahead and do that. Does that make sense? Okay, I'm just trying to save some time here. All right, if this information is given to you, let's go ahead and draw the picture. Here's A, here's B, and here's C. This is 42 degrees, right? This is 22 feet. This one over here is 12 feet. So analyze what you've been given. You have been given an angle, a side, and a side. If you've been given angle, side, side, you automatically think what? Ambiguous case. And if you think ambiguous case, then how many situations could there be? 3. One triangle, no triangle, or 2. This is an example of one triangle, but we're going to pretend that we don't know it yet, okay? So we immediately go figure out our leftover parts, or our leftover angle. How much do we have left over to spare? 138 degrees. You guys, everybody agree with that? I have 138 degrees left over to spare. Okay, good. So then I go and I figure out the only law of sines that I can. And that is this. The sine of 42 over 22 equals the sine of b over 12. Therefore, the sine of b is worth 12 times the sine of 42 over 22. Therefore, b is the inverse sine of whatever that number happens to be in the calculator. Did anybody get it yet?
21.
Oh, so whatever this is, like what's the decimal in here? 0.36, blah, 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 which is approximately 21 point what? 4 degrees. Okay. What's the other one? Now that one's okay because that's less than 138, right? What's the other one? Yeah. What's the other one? Take 180 minus that. 156.8, which is way more than that one. So it can't be that one. So therefore, it's only one triangle that can be drawn. And you just use the law of sines to figure it out from there. Okay. Okay. This is an example of no triangles possible, and we're going to see how to get it. So let's say you've been given this information. You just go ahead and make your little sketch to get some information out of it. So this is 85 degrees. This is 15. This over here is 25. So what have we been given, everybody? We've been given an angle, a side, and a side. So we automatically think ambiguous case. So how much do we have left over to spare? $95 degrees left over to spare? Okay, so we have 95 degrees left over to spare. Alright, so we're going to set up the only law of sines that we can. So we're going to do sine of 85 degrees over 15 equals the sine of angle B over 25. So B is the inverse sine of 25 sine 85 over 15. Okay? So we're going to use this to plug this into our calculator right now. So check this out. Yeah, when I take the inverse sine, actually I'll do it my normal way because I want to point something out. 25 times the sine of 85, right, is some number. And then when I divide that by 15, okay, just pause for a moment, okay? Look at this number. This is the number 1.66. If I round, that's 1.67 or 1.7, right? I'm asking the calculator when the sine curve, at what angle does the sine curve reach 1.7? Think about that. It never does. How come? Because remember, think about the sine curve. The sine curve lives between -1 and 1. This is the sine curve, right? And I'm asking the calculator, that should be positive 1. I'm asking the calculator, at what angle will it be 1.6? Never. There's this big gap between it. It'll never reach that. Isn't that cool?
It's above 1.
It's above, or if it's above 1 or below -1, they'll never get there. So here's what you get. Let's say you didn't make that connection, and you just went ahead and just did, okay, inverse sine of this answer, whatever, right? And you're just blindly going at it. Your calculator's going to be like, hey, not going to happen, buddy. That's a domain error. So what does that mean? That means that you could never draw a triangle given these 3 pieces of information. It's not possible. And this is the reason why behind it's not possible. So it's really deep understanding of why you cannot draw a triangle given an 85-degree angle and 2 sides of 15 and 25. So whenever you come into this situation, all you gotta do is say, oh, no triangle possible, and you're done with the problem. That's the easiest one of them all.